For more than 100 years, a single number has basically been the absolute speed limit for our universe. But we've always been obsessed with what that limit is, not why it's there in the first place. So, in this explainer, we're going to dig into a pretty wild idea. What if the speed of light isn't a speed limit at all, but something much, much stranger?
We all learned this back in school, right? Nothing with mass can hit the speed of light, and absolutely nothing can go faster. It's like the ultimate cosmic stop sign, a rule that's just woven into the fabric of reality. It's a constant, for sure, but a constant of what? And that right there is the real mystery, isn't it? Why that exact number? Not a nice round 300 million, but this super specific value. Physics is great at telling us what the number is, but it doesn't really get to the why. And to do that, well, we have to completely flip the way we think about the problem. Okay, so let's try to reframe this whole thing. What if we stop thinking about the universe as some giant empty highway with a speed limit? What if instead we start seeing it as a massive computer, a huge information processing system? Suddenly, the question isn't how fast can something go, but how fast can reality itself think? This is a total game changer in terms of perspective. On one hand, you have the old idea, a universal velocity limit, kind of like the top speed of a race car. But on the other hand, you have this new idea, a universal processing rate. Think of it like the clock speed of your computer's CPU. The speed of light isn't how fast things move through space, it's the top speed at which space itself can update information. This brings us to a concept called a discrete informational substrate. It's a mouthful, I know, but the idea is pretty simple. It suggests that the vacuum of space isn't the smooth, empty void. No, it's actually made of these tiny fundamental units, kind of like the pixels on your TV screen. And the speed of light, well, that's just the maximum refresh rate of reality. It's the fastest that one of those pixels can pass its information to the next one.
So, if reality is this giant processing system, what are its operating rules? What's the code it runs on? This is where a framework called Triune Harmonic Dynamics, or THD for short, comes into the picture. It proposes that a really fundamental 3-6-9 pattern is the hidden engine behind all change and transformation in the universe.
This equation you're seeing, developed by the researcher Kevin L. Brown, is pretty much the mathematical heart of THD. Now, you don't need to be a math whiz to get the big picture here. Think of it as a map that describes a universal rhythm. First emergence, then tension, and finally, resolution. The theory suggests that everything from the smallest atom to the biggest galaxy follows this one, single, structured pattern of change.
So, the THD cycle is basically a three-step dance. It always kicks off with phase 1, emergence. That's the birth of a new idea or a new state of being. Then you get phase 2, contrast. This is a period of tension, of testing, that really refines whatever just emerged. And finally, you get phase 3, integration. This is where all the pieces get synthesized into a new, more stable, higher order. And once that happens, the whole cycle just starts all over again.
Okay, so how does this kind of abstract 3-6-9 pattern connect to the actual physical properties of empty space? Well, THD might just give us the key to decode why the speed of light is what it is by tying it directly to the fundamental mechanics of the vacuum.
You see, the speed of light actually comes from two fundamental constants of the vacuum. The first is permittivity, which you can just think of as the stiffness of space when it comes to an electric field. The second is permeability, which is like the elasticity of space for a magnetic field. The speed of light pops out from the perfect balance, the perfect impedance match between these two forces. And here is where it all clicks together. The 3-6-9 pattern seems to map perfectly onto these physical properties. The number 3 represents potential. That's the electric field. The number 6 represents tension. That's the magnetic field. And the number 9? That represents resolution. It's the point where the electric potential and the magnetic tension come together and integrate into a stable, coherent wave. And that resolution is the speed of light, c. It's the phase lock speed where the universe actually works. All right, this is a really cool idea, right? But is it actually science? Because a theory isn't just a good story. It has to make predictions that we can go out and test in the real world. And most importantly, there has to be a way to prove it's wrong. This is what's called the principle of falsifiability. It's a cornerstone of science. Basically, if you can't even imagine an experiment that could disprove your theory, then it's not a scientific theory. So if this THD model for the speed of light is going to be taken seriously, it has to make some very concrete, testable, and falsifiable predictions. So prediction number 1,
is the informational drag test. The idea is, if reality is basically a data network, then a traffic jam of information, say an area with a ton of quantum entanglement, should slow things down, creating a tiny bit of lag. So the test is simple. Measure the speed of light in a really high data area and compare it to a low data area. And here's the key. If there's zero difference, if that speed is perfectly identical in both places, then this whole bandwidth theory is just wrong.
The second prediction is even crazier. If the speed of light really does depend on the stiffness and elasticity of the vacuum, could we change them? The test proposes using a special resonant cavity that's tuned to that 369 pattern to try and locally tweak the fabric of space. The falsification criteria is dead simple. If we try this and we can't manipulate the local value of C at all, then the theory is incorrect, plain and simple. And finally, we have the quantum refresh rate test. Look, if space has a frame rate, it can't be perfectly smooth. It has to be pixelated. To test for this, we can look at incredibly high-energy gamma rays that have traveled for billions of light years to reach us. Over that insane distance, any pixelation of space should cause a tiny bit of blurring or spreading in their arrival times. And if we look and find zero dispersion, that means space is a perfect continuum and the whole refresh rate idea is wrong. This quote really just nails the whole concept. It suggests that 299,792,458 meters per second isn't just a speed. It's the rate at which cause can lead to effect in our universe. If anything moved faster, you could have an effect happen before its cause was even fully computed. And that would basically be a paradox, a system crash for reality itself. So why does any of this matter outside of some wild physics theories? Well, there could be some absolutely incredible applications. If we truly understand the universe's refresh rate, we could, in theory, build communication tech that syncs up with it. We wouldn't just be sending data anymore. We'd be syncing states. We could create networks with virtually zero perceived lag. And that leaves us with one final, kind of mind-bending thought. When you start to see the speed of light not as some fixed, unbreakable limit, but as the clock speed of reality itself, it opens up a whole universe of new questions. If the operating system of the cosmos has a refresh rate, what other fundamental settings are just waiting for us to figure out the code?